Hi, my geometry students. We've got lesson 214 on double triangle proofs. So this is the last new day of notes for the unit, and then we've got a couple of days of review coming. So what a double triangle proof is exactly how it sounds. We're going to prove one pair of triangles congruent so that we can steal the parts using CPCTC to then get a second pair of triangles congruent that'll ultimately get us to our final goal. So lots of steps here. We have the whole page, so give yourself a nice statements and reasons column so that we can get going here. All right, what I want to do is let's set up some goals. So if you're looking at this, they're going to tell us a couple things. We've got some pairs of congruent segments, and it's actually worth it. So let's just get that first couple of givens down, and then you can kind of see where the goals are going. So that first given, that AEB, is just clarifying the diagram. Just throw it in there. All right, then we have AC is congruent to AD, and let's mark that in the picture. So AC and AD. And then we also have that BC is congruent to BD given. All right, let's mark that. BC, BD. Okay. When you look at this, they are handing us two pairs of sides, but you have to think of what triangles. So if I actually look, I'm going to take my yellow marker here. I have like AC and CB here. If I close that up with AB, I could get a triangle right there. And then I could do the same thing. Let me grab a different color marker here. If I use AD and DB here and close it up with that same side, AB. So that's actually going to be my first goal there. All right, so from this, let's make goal number 1 be to get triangle ACB congruent to triangle ADB. Right? And so the only step we need to be able to do that, here's one pair of sides, here's a second pair of sides. We need this guy right here. Let's do a little reflexive. So let's use that segment AB is congruent to segment AB by the reflexive property, which is going to give us our third pair of sides. And then right there, we're going to have that first pair of triangles congruent. All right. So triangle ACB is congruent to triangle ADB, and we're going side, side, side. All right, here's the reason we wanted those steps. We are ultimately working towards proving that segment CE, so that's this little segment, is congruent to segment DE. To be able to get this, we need a pair of triangles that segment CE and DE are actually in. So what we might want to do in this case is try to prove either this smaller triangle, ACE is congruent to ADE, or we could use the triangles on the right. It doesn't matter. I'm going to go with the ones on the left. So I'm just going to kind of shade them in to focus ourselves here. So this was sort of goal number 1. I'm going to make goal step number 2 be that we want to prove triangle ACE congruent to triangle ADE. All right, now let's think about what we need to be able to do that. For those triangles, AC and AD are definitely sides in those triangles. So I'm going to use just a red pen right here. And AC and AD, all right, that's going to be a pair of sides for my second pair of triangles. So we got that down, all right? What else do we need? Well, the whole point of proving this first pair of triangles congruent was so we could steal the parts using CPCTC. So let's take a look. In my yellow triangle and in my purple triangle, they both have this angle here congruent to that angle that they share with this little pair of triangles. Let's make life easy, call it angle 1 and angle 2, and let's make that step 4. So in my proof, I'm going to say for step 4 that angle 1 is congruent to angle 2 because corresponding parts of the triangles we just proved were congruent have to be congruent. All right, so we get 1 and 2 right there. That's going to give me a pair of angles in the second set of triangles that I'm working on. All right, so let's see. We've got sides, we've got angles, and now we can use the exact same thing we did last time. They still share that side between them, side AE. So let's use reflexive again. So we can say in step 5 that AE is congruent to AE by the reflexive property. And now that's going to give me a pair of sides between the two triangles. All right. We've got side, angle, side. I don't know if we have it in that order, so let's take a look. Yeah, we do. Side, angle, side right here. Side, angle, side right here. All right. That gets me goal number 2. I'm going to slide it up so you guys can see it. So in step 6, I was able to now say triangle ACE is congruent to triangle ADE, and it's by side, angle, side. All right, but we're not quite done yet. Our final step is we are trying to prove that segment CE is congruent to segment DE. Well, CE and DE are parts of that second pair of triangles that we prove congruent. So now we're allowed to say in step 7 that CE is congruent to DE. And our reason, again, is corresponding parts of congruent triangles are congruent. All right. So it's only 7 steps, but we got to think about what the heck did we do? We took what we were given to figure out, all right, what triangles can we prove? The easiest triangles for us were the yellow and the purple ones. So we started with that. Then we stole pieces of the yellow triangle or yellow and purple triangles that would help us work towards the triangles we really needed to be able to get this using CPCTC. So you kind of have to just take what you're being given and roll with it. So keep that in mind when we flip to the next page, because the next one, there's multiple ways to do it. And we're going to try to see, like, what's one way? What's a way that we can take what we're being given and run with it? All right. So flip it on over. Last proof of the day. There's a lot going on in this diagram, so get yourself set up. So we got statements. We got our reasons. And now that you've seen one, let's take a little walk through this one and see if we can game plan it a little bit. Okay. This whole first line of givens is all just clarifying the diagram. Go ahead and just put them down. They're just telling you have a straight line segment PQ, segment PAB, PCD, AQD, and CQB. So they're not giving you anything congruent. They're just clarifying those are all straight line segments. Nothing crazy there. All right. While we're at it, let's put those other actual givens in here. So angle 1 is congruent to angle 2, and AP is congruent to CP. All right. If we mark those, that's going to give us a game plan as to where to go. So angle 1, whoops, congruent to angle 2, and then AP congruent to CP. Okay. Where we're eventually going with this proof is we're going to want to prove that segments QB over here and QD are congruent. So we're going to need triangles that QB and QD are in, but that's not our concern at the moment. What triangles can we prove are congruent based on the information that they're giving us? So for me, when I'm looking at this, if I trace over this side and then over that angle right there, it's kind of naturally giving me that little triangle right here. And then same game over here, CP, if I kind of trace it with PQ, naturally giving me that triangle right there. Make sure you guys, you can use colored pencils if you like. There's plenty of them in the classroom if you don't have your own. All right. So I'm going to say goal number 1. That's to be to get these little triangles congruent. So APQ congruent to triangle CPQ. All right, so let's think about it. Angle 1 and angle 2, that's a pair of angles in there. Bam. AP and CP, there's a pair of sides. We got 2 steps in. What else do we need? I'm hoping right now you're like, ooh, I know it. We've got a shared side between them. So QP is congruent to QP by the reflexive property. And right there, we've got 3 pieces that we need to get those triangles congruent. As long as they show up in the right order in the diagram, which if I take a look, side angle, side there, side angle, side here, we are looking good to go. So we've got goal number 1 done. Triangle APQ is congruent to triangle CPQ by side angle side. Okay. This one, like I said, is a little bit different than last time. We're still going to want to steal parts from these triangles because that's the whole point. So this next step, once I prove the triangle's congruent, better always be talking about a little CPCTC, all right? But what I want to think of is what triangles are we going to have to prove so that we can actually get the parts that we need. So when I look at this, like I said, there's a couple ways to do it, but what I think is going to be easiest is QB is part of this little triangle up here. So I'm going to shade in this triangle up here. And then QD is part of this triangle up here. I want to make that our goal. So we want to think about how can we use what we've done already, steal some pieces to help us work towards this. Okay. So goal number 2, let's work towards getting triangle BAQ congruent to triangle DCQ. All right. So let's think about what parts do these 2 triangles share with my shaded triangles up top. What I'm hoping you're noticing is that side AQ is in the yellow triangle, CQ is in the purple, but they're also in the triangles that we want. So let's use that as our CPCTC step. So I'm going to put a little double swipe on each of those, and down in my proof, I'm going to make AQ congruent to CQ, and there's my CPCTC. All right, so I stole a part. What that gives me a pair of sides in my new triangles. Okay, so there's one step. Bring it on back. Okay, here's where I'd like to use something new. Yesterday's notes, we used congruent angles implies congruent complements, and congruent angles implies congruent supplements. You know how they took the time to tell you that these are all straight lines? If I look in my picture, this angle right here, angle QAP and angle QCP, those are congruent, right? Because these are corresponding parts of the triangles. That'll help us get the angles next to it, which would be the supplements. Crafty, right? So, as always, you know I like to make life easy. Let's make this 3 and make this 4. And that, I'm going to say, using CPCTC, so I'm going to smush it right in to the step we just had a second ago. So angle 3 is congruent to angle 4, but it's not a pair of angles in my new triangle, so I'm not going to put an A next to it. What we're going to do is let's use that to get a pair of angles in the triangles that we want. All right, slide it on back up. Okay, I'm going to give myself a little space here. Let's call the angles next to 3 and 4. Let's call them 5 and 6. If 3 and 4 are congruent, 5 and 6 now have to be congruent. That's a pair of angles in the triangles. Now we're moving in the right direction. So we get to say here, angle 5 is congruent to angle 6. And then from yesterday, we get to say congruent angles implies congruent supplements, or congruent supplementary angles, however you want to say it. Cool. All right. That's a pair of angles in the triangle. So I've got a pair of sides, I have a pair of angles. Go back and look at that picture. So I'm going to slide mine back down. We've kind of taken all the stuff we can from CPCTC. We took the shared sides, we used the supplements. So look at the diagram itself. In the diagram itself, I hope you're seeing that X shape right there. The last thing that we're looking at, we got a pair of vertical angles right there. If you can believe it, I don't think we've done this yet this year. I'm going to call these 7 and 8. Of course, you can use the letters, but it's just easier. So please make sure to label your diagram appropriately. And we can say angle 7 is congruent to angle 8. And our reason would be that we've got some vertical angles here. So vertical angles implies congruent angles. All right. That gave us a pair of angles inside the triangles that we want. So if you go back up and look at the diagram, triangle on the left, here's my angle, side angle, triangle on the right, angle, side angle. We've got enough to say that second pair of triangles are congruent. All right, step 7. Triangle B, whoa, sorry, breaking pencils here. BAQ is congruent to triangle DCQ, and it's by angle, side, angle. All right, there was our second pair of congruent triangles. And now what we can do is we can finish our proof and say that that means if these triangles are congruent, it must be true that QB here and QD here is congruent because those are corresponding parts of the congruent triangles that we just proved were congruent. So finish it up. QB is congruent to QD, and we did it. Woohoo! All right. You can tell these are a little lengthy, so that's why when you go to do the homework, there's not a ton of them. All right. Keep in mind, homework tonight you've got in the packet, and then next week we are doing review. Good luck with all of it. My hope is to see you back in school on Monday. Thanks for watching, guys.